Alright everybody, so we're going to be working on examples 1, 2, and the monitoring progress problems that we have for day 21 of geometry. Let me make sure I got everything. Yep, I got everything. Okay, so example 1 says, is either triangle DEF, which is this one here, or triangle GHJ, which is this one right here, similar to triangle ABC? So at this point, we already should have learned about the side similarity theorem, not to be confused with the side congruence theorem. So because we know that if all of the three sides of a triangle are in proportion, that those triangles are going to be similar, we're going to try and set up these ratios. So what I'm going to do is I'm going to find my appropriate colors, and then we're going to try these out. Let's see. So if this one and this one are similar, they gotta have equal corresponding sides. So I'm gonna go ahead and I'm gonna set up these fractions, these ratios. So we're gonna go 8 and 6, right? I even color coordinated these, so these should be easier to keep track of. And we know that that should be, if these are similar, these should be equal, and we don't know this yet, so I'll put a little question mark here. And then we'll do 16 over 12. And then this is maybe equal to 12 over 9. Now if I were to simplify these fractions, which I will, I'll put them down here. So we know that 8 divided by 6 is actually the exact same thing as 4/3. Oops, I see it's a little tiny. Let me zoom in. There we go. So that's 4 over 3. If I simplify 16 over 12, that is 8 over 6, which is again 4 over 3. And if I simplify 12 over 9, I gotta divide both sides by 3. And so that tells me that I will be getting 4 over 3. So notice how we get the same exact corresponding ratio there. This tells me that. And I'll write the answer right here. So triangle ABC is similar to triangle DEF by side similarity theorem. And now let's check if this one is similar to it, but the way that they phrase this question probably leads us to believe that it's not going to be. But even then, let's go ahead and let's figure this out. So just like before, I'm going to try and set each number with its respective corresponding side. We're going to do 8 divided by 8. And again, that's got to be equal to, I'll put equal to. So that's got to be equal to the blue side over the blue side, which would be 16 over 16. Over 16, right? So big side. And then the third and final side is going to be 12 over 10. And now if we start to simplify these, we're going to get a very obvious mistake here. 8 divided by 8 is 1. 16 divided by 16 is also 1. But 12 divided by 10 is not 1. It's actually 6/5, right? Or 6 over 5. And so because 1 is equal to 1, but this one over here is not equal to 6 over 5, that means that those two triangles cannot be similar. And so we confirm that this right here needs to be our answer. This triangle and this triangle are similar. Using the same exact properties from the side similarity theorem, we're going to go ahead and we're going to solve example number 2 down here. So it says the following: find x. So we see two x's here. Find x that makes triangle ABC, which is this little one, similar to triangle DEF, which is this bigger one here. Now, if just like we said over here, if these two triangles are similar by side similarity theorem, we're going to need all of their ratios, all of their corresponding ratios, to be similar. In this case, however, we don't really need all three fractions. We only need two fractions. One of them has to carry the x, obviously, otherwise we cannot solve for x. So I'm going to go ahead and pick BC, which is x minus 1. And the side that corresponds to BC is going to be EF over here, so we're going to divide that by 18. And then this should be equal to, and now we can use a value of x. Let me see, we're going to use, let me see, can we use this one, 8 over x? Yeah, now we're going to use another one, so let's see, we went from small to big, so we got to do the same thing, so let me do 4 to 12. 4 to 12. Right, so small to big, small to big. And now we're going to do this the exact same way that we've been doing this before. We're going to just cross multiply here because these two are in proportion. We're going to multiply like an x. And so the next step should be 12 times x minus 1 is equal to 4 times 18, which is 72. Alright. And then if we want to solve for x, we could distribute this in there, but I'm going to just go ahead and solve this in a more straightforward manner. It requires that I divide both sides by 12. Like that. So if I do this, the 12 actually disappears from here. It's actually a 1 now. And all we are left with on this left side is going to be x minus 1 is equal to 72 divided by 12. If we know our timetables, that should be 6. And then if we're really good at mental math, we can figure out that some number minus 1 gives me 6. That secret number should be 7. But let's pretend we don't know mental math. We're going to use the algebra rules. We're going to add 1 on both sides. It disappears from that side. And so now we have that x should be equal to 7. They wanted us to find the value that made these two triangles similar, and here it is. This tells me that this side of this triangle ABC is actually 7 minus 1, which is 6. And that tells me that this side right here of the bigger triangle is going to be equal to 3. 7 plus 1 is 8. So this is 24. So a quick inspection definitely shows that these are in proportion. We have 4 over 12 here. That's 2 over 6, which is 1/3. We do the same thing with the new sides we just found. We're going to get that 6 over 18 is 1/3, and 8 over 24 is 1/3. So this confirms that this is the correct value of x that will make both of these triangles similar. And then last but not least, because this is about the same thing, I'm going to just squeeze it in this video as well. The monitoring progress questions. It doesn't make sense for me to make a separate video for it if we're talking about the exact same concept. So here it is. I apologize if this video is a little bit longer than usual. So the monitoring progress questions are asking us almost the same thing that we were being asked before. Which triangles are similar from these three? Now the other one was really easy because they color coordinated the side lengths for us. This one is not so obvious, especially because I drew it freehand. Look at how ugly these triangles are. They don't even look the same or similar at all. But geometry consists of us not trusting our eyes and actually proving what we are seeing with math. And so that's what we are going to do. Just like in this example, let me pull it up real quick. Just like over here, where we needed to set this triple set of ratios there equals to each other, we're going to need to do the exact same thing for these. Now, for these, I'm going to go ahead and just start in order. So I'm going to check if these two triangles are similar. And then if that doesn't work, I'm just going to check if this one and this one are similar. Let's see. So if I'm using these two, for now I'm ignoring this one. So if I'm using triangle LMN and triangle RST, what I have to do is I have to start building these ratios. And because they are not color coordinated this time, I'm going to just go by length. So I'm going to pick the longest side in this triangle, which is 26. And then I'm going to divide that by the longest side in this triangle, which happens to be 33. And again, if these are similar triangles, all of these should be equal. But because we don't know that yet, we're going to put an equal sign and then a little question mark on top. Like that. So longest side over longest side, and then we'll go to the medium side. So that one is going to be 24. And then we're going to divide that by the medium side over here, which is 30. And then the remaining side is going to be 20 over 24. And so quick use of my calculator here, we're going to speed this up. Tells me that 26 divided by 33 cannot be simplified. It stays like that. 24 divided by 30 is actually 4/5. And 20 divided by 24 is actually 5/6. So each and every single one of these things is different. So because this is not the same, triangles LMN and triangle RST are not similar. So now let's try these two and see what that gives us. We're gonna go again with the longest, with the biggest side of each triangle. So over here, I'm gonna start with 26, and I'm gonna go ahead and divide that by 36, because that's 39. Sorry, because that's the longest side over here. So 26 over 39. And once again, we don't know if this is equals, so we'll do that question mark business here. So 26 over 39, then we pick the second biggest side, which in this case would be 24. And we're going to divide that by the second biggest side over here, which is 36, I should say, sorry, 36. And then last but not least, we'll have 20 divided by 30. And so once again, I'm going to go ahead and I'm going to type this into my calculator, see what that gives me. So 26 divided by 39 is 2/3. And then we have that 24 divided by 36 is 2/3. And then we have that 20 divided by 30 is 2/3. So because all of these are actually 2/3, we can finalize this answer and we can say that triangle LMN is similar to triangle. And here I gotta make sure, remember, we need to make sure that we're naming these vertices in the right order. So let's see, we have our longest side over here. Let me just make sure I'm not telling you guys the wrong answer. So it's gonna be Y. Let me see, if this is LMN, we're gonna have to go Y ZX. So this is our similar by SSS similarity. It's not going to fit, so I'll just do dot 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 similarity theorem. And then last but not least, we're going to have this last this question number 2 for monitoring progress. It says the shortest side of a triangle similar to our triangle RST is 12 units long. Find the other sides. Alright, so the shortest side of a triangle. Alright, so we're going to just draw any triangle here. Any triangle, I'll make it like this. Like that. And it says the shortest side of a triangle similar to triangle RST. We'll pretend that that triangle RST is this one. Something like that. So these two are similar. And now the shortest side, which is this one, is similar to triangle RST. And that's going to be 12 units long. 12 units long. Like that. So, hold on. I may have written this one wrong. Let me double check. Short side of a triangle similar to triangle RST is 12 units long. You know what? Yes, I think I wrote this one down. So for now, we're going to go ahead and ignore this. So ignore number 2. Just leave it at number 1, and we'll go over the correct version of this problem in class.